Hello, everyone. My name is Artyom. I'm the founder of education platform DevOps01. So today we have something special for you. So I will not be the main lecturer for the next 4 sessions. So it will be Sergey Marunich with his mini course about Istio and how to achieve mastership in configuration Istio. So Sergey, I'm very glad to see you with us, and the good news that we already covered all funds for the charity as we discussed it. So the main goal is achieved. The next goal is to gain some knowledge. So Sergey, stage is yours.
Righty, perfect. So let's get started. So let me share my screen. Can you see my screen?
Yeah.
I guess there's thumbs up, reactions, all folks again. Please, it's just 10 of us. So I would appreciate if you have any questions, just feel free to interrupt and, like, hey, I have a question, right? It's 8 hours class, technically. So it's a day class, technically, that will, spread through 4 days. So let's just start. Let me just get going with all this. So I'll do something here. I'll enable the questions that you can pose over here. If you can see my screen, there's a link that will enable you to post a question in there, so everyone can see that question after one, and I can answer that question during the session when I deliver, or after the session. Basically, again, this is the sort of saying you see there. Just go there, write a question, I'll answer that. So let's get going. So about me, I've been basically doing Tetrate or Service Mesh for the last few years with Tetrate.io, right? So I've been basically in the startup industry for quite a while right now. This is my 4th startup, been in other vendors. Been living in Canada since 2011, born and raised in Kharkiv, Ukraine. So the rest of the details you can find there, but usually I don't like to talk about myself. So let's get going. So what we have here, right? This class will be a service mesh class that we'll be talking about this year, right? So to set the foundation, there are things that I assume that you know. If even you don't know, again, feel free to ask. I'll be happy to answer. But it assumes some basic knowledge with Kubernetes, so some basic experience with Docker and Linux, right? And a lot of that, what I'll be talking about, implies that you will have to do yourself, meaning that it implies that you will be able, basically, as I will be going over those exercises or over the theory, all of that you will be able to practice, right? So it's a hands-on class, which is, I think, the most important portion of it. It's not just theory. However, the first couple of hours of that, there will be quite a decent amount of theory that we have to cover. So technically, the way how I'm doing those classes, and I'm not necessarily doing a lot of those classes, but technically the way how this class is built, it's 8-hour class. So it's built to be a day class where you basically go from 0 to 60 miles an hour. It's called Istio 0 to 60 or 0 to 100, you call it. But the point is there from absolute zero amount of knowledge of service mesh of Istio, the class is built to basically enable you to employ it in sort of your environment, or at least let you understand what the service mesh and Istio, and how Istio works together. So technically, the way how I'll plan it, so it's 2 hours for the day. So if it's 2 hours for the day, hold on, is there a question there? Right, perfect. Thank you for sending the link. Yes, if it's 2 hours for the day, I'll probably be breaking once during those 2 hours. We'll figure out, we'll be just in the middle. Maybe it can be before, later, we'll figure out, right? I basically expect to break in 50 minutes from now and for 5-10 minutes and continue again, right? So once again, I would really welcome if you ask any questions at any moment of time through the forum, or just basically taking a chance and basically using the mic and talking over. So from the language standpoint, I'll be quite honest, right? Like, it happened to be in my life, like the thing's been, language-wise, I'm very open to any language. So if you per se don't understand me, please let me know. If you hesitate to ask the question in English, feel free to ask the question in Ukrainian. I'm fluent to the very extent of it, but it happens to be we record discuss in English, and it's much easier for me to deliver this content in English, right? So once again, I would expect the questions. I would expect your participation. I just don't want to be talking for 8 hours to myself, right? So let's keep going. So I'll just briefly go over the contents so you understand what to expect from this. Something to call out, I will be sharing the slide deck and I'll be sharing the lab materials with you. So whatever you'll see here, you don't necessarily need to screenshot it, you'll have those decks and you'll have the training materials after on with you. So as we talk about the content, so the focus of today's session will be to understand what the service mesh is and acquire basic hands-on experience with a service mesh from the point of today, right? And then throughout all those four sessions, we'll be going over a set of different topics as we open the service mesh value, as we open to understand what Istio is, we'll be covering the topics that pertain to the service mesh, right? So like it's a collection of topics, right? Technically, they're there if someone is like, didn't see the class before, don't understand what that is, they'll just, oh, that's what I'm here for, right? I would expect you all sign up for a reason, right? So you should be, you don't understand that I'll be talking about the service mesh. So basically, as we'll be going over the content, I'll be explaining the topics that you'll see here. So once again, the labs and the slideware will be shared with you. First, where are the labs? The labs are there. You'll see the link. I'll send you this link. Please don't rush to jump to that link. We will be talking when the first lab will approach. You'll hit the link, and we'll be talking about how to get your environment, to get started, etc. Right? It's a slide where it'll be shared with you, so you'll have the content and links there. Talking about where you will run the lab, there are a few options there. I want to call out, right? Like I will not be providing your to you the Kubernetes clusters, right? But what I would expect, or if you have your own, or what you can do, you can use Killer Quota, which is sort of preset Kubernetes cluster, or you can use K3D or other means. But what you will need for this class, you'll need a single instance of a Kubernetes cluster to apply, what we'll learn here, right? So basically, think about that, how you'll, how we'll start with that. But long story short, I will say the link. I would expect K3D or Killer Quota will be perfect start for you. And then as you'll be going through, you'll figure out for the next time, which is the next session on Friday, you'll figure out the environment of your choice, which technically for the Friday, it will be more important than for today. For today, it's almost not important because today will be more, much more theory than practice, but the next 3 sessions will be a lot about practice. It's a lot about how the things work and how and why they work like that and why they are there, right? So don't rush there. We'll get there later. So this is like, we will not be doing the lab environment setup as of now. We'll go with theory, and then when the time is there, we'll signal for that, and we'll be walking through the lab together. So that's where the class starts. So end of logistics, end of how we'll be operating, and let's start the class. So basically, let's define why we need service mesh, why we're talking about service mesh, and what are the actual problems that we're trying to address with service mesh, or what are those problems are there that service mesh, service mesh is trying to address with service mesh actually came as a saying, right? So there's, 2 parts to it, right? There's first is the business story, right? And there's a technical story, right? The business story is simple as that. If you hire a developer, right, to write the business logic, meaning that to write the banking application, to write the marketing application, to write all kind of software for the developer, you would expect to pay developer for his actual primary responsibilities of building the banking app, building the trading app, but not building the network stack for it, not building the observability stack for it, not building the routing stack for it, because that's sort of a commodity functions that developer have to employ in order for his stack to operate, right? And this is sort of a business function, and that's where like there always will be 2 angles. But if you think about how how and why for the higher level, like basically for higher level executives. Why service mesh is important, because technically, what do you want to do? You want to maximize the resources that you have. What it means by that, you want to basically let your developer develop what they're being paid for, instead of having a team that you have 8 developers and only really half of the team is focused on the core business function, and another half of the team is focused on supporting the core elements to run those functions, right? And that's basically the bottom line, right? And to be fair, that's what it is right now. And like, does service mesh like change the landscape, significantly? As of today, not really. We'll talk about different elements, right? But there are number of the problems around that, as a developer, endorses are built out. I'm talking completely about, this is not platform conversation. This is not infra conversation. As a developer, I want to build out a production grade app. I'll be facing issues, right? And those issues that basically can go from the point of, first of all, of course, we talk about microservices applications, right? So if I embark an idea of microservices application, if I embark an idea of building that distributed microservice application, not a monolith, I end up at the point I have multiple services that together will form an app, that somehow they need to discover each other. Somehow they need to send traffic amongst each other. Somehow they need to reliably send the traffic amongst each other, right? So that's basically where this is very important theory to understand before we'll talk about Istio, before we talk about service mesh. There are like components such as service discovery, how you achieve a service discovery within the Kubernetes. You should already basically answer this to the point, well, I have, what I have here, I have my Kubernetes services, basically a Kubernetes service, it's a valid object. In fact, when you go to Kubernetes, you can actually go and connect those services together, right? Meaning that like service A can call service B. Why? Because you have DNS resolution that operates within the cluster, right? You have the Kubernetes services that form so-called endpoints that allow you to basically centralize those entrances between the services. So, and in fact, yes, Kubernetes off the box, by default, by definition, does solve in very basic terms service discovery and service registry issues or problems per se, right? And it's important to say, like, when we say service discovery, it implies service A needs to talk to service B, but eventually service A needs to discover all the endpoints that service B has. So how it will happen? So I will assume in Kubernetes you already know how it will happen, but is it that sufficient? Can you scale this across multiple clusters? How, right? And that's actually there have been actually attempts. There is MCS, which is a standard called multi-service cluster IPs, right? They've been trying to attempt to fix it from a different angle, right? But that thing never landed anywhere, right? So basically, the long answer short, no. But that's like first thing that I want you to remember, how to do service discovery. You can see, well, there are attempts there. But the next is when you go to Kubernetes, how to do load balancing. Again, like you say service A, you know service B. So how it works right now is in the Kubernetes. It's simple as what? As proxy, splitting traffic across those instances of service B, right? So it's an intelligent load balancing. Is it load balancing to the way that you know? Can you do like proper traffic management with that? Can you do timeouts management? Can you do retries management? Can you do traffic monitoring? None of that you can technically do, right? And I'm not talking about, and then this is like an example. So we talk about TCP level stuff, but there's also how about manage it in more granular version, more granular way from the point of how to manage it from the point of the traffic. Like if you go to HTTP, can I perform a specific HTTP processing for the specific request? For example, if this service A calls this service B, so green replica should be used versus blue, right? For example, how can I do simple, pull grid deployment in this case? Not going sort of in that door, but what's important here is, you see, I'm on purpose started talking about that from the point of Kubernetes. From the point of Kubernetes, can Kubernetes achieve service discovery? Can Kubernetes achieve load balancing? And this is a thing where, why we're saying everything is Kubernetes? No, it's not about Kubernetes. I was just giving an example to bootstrap this conversation, but technically those issues that I'm listing, they're not platform centric, right? The problem is, like, this is the issues that I'm a developer, I'll hit service discovery. Do I care where those services deployed? Is my service a cloud native service? Is it Kubernetes service? Is it a VM-based service, right? I still need to address those challenges that I'll have, right? So don't think about, like, for example, don't equalize service mesh to Istio capability, right? It's not what did I say, like Istio capability? Don't equalize service mesh to Kubernetes, right? Service mesh is beyond Kubernetes. Service mesh, I'm not talking about specific implementation of it. And when in fact, Istio is beyond Kubernetes. What I'm trying to call out here is their set of challenges that you will hit in any sort of environment that somehow have to be holistically addressed. And the key here is holistically to be addressed, right? So to continue there, like, those challenges can be, how can I achieve resiliency, or how can I actually encode resiliency when services, when my microservice application has collection of the services, and how those services will resiliently handle all those cross services failures, right? And this is pretty much, by definitions, achieving resiliency within the microservices is a challenge. So, and this is an example, this is a set of the problems that I'm trying to list here. They pertain to the point of reliability, resiliency, and traffic management, right? But there is also a different group of issues that you can think about. Is if you go and build an application, any application, you'll be tasked to the point you have to have encrypted wires. That's it. Like, you can't build none of the applications today. You can't go to production without having without having encryption within the services, right? So here's the thing: like, for monoliths in the past, there was never the challenge because monolith was so coupled, so you don't need to basically encrypt those cross monolith communications. But as soon as you go to microservice architecture, by definition, you open that can of worm when you have to now address regulations that you didn't have before because it was a monolith. And now if you have distributed services, right, you have to encrypt the traffic. This is like always any sort of environment that you will go with, I have to encrypt, like, basically perform variant encryption of general communication encryption, right? So, and this is a problem statement, right? How to achieve this? Again, like, as a developer, right? And this is very, as a developer, I'm being tasked with that. I'm not an infrastructure person, I'm not a platform person. I'm a developer. I'm building this application. I'm having an infosec coming to me and saying, you can't publish this in production because guess what? You don't have a cross services encryption, or within the services encryption being enabled. And as a developer, it's like, okay, I have to again come back to what I have. Oh, well, I need to employ a specific library to enable the encryption between those two services. And then it goes to the point, well, you again come to InfoSec and say, well, I encrypted. And InfoSec again comes back to you and says, well, how frequently you rotate the certificates, where you get those certificates, or how you manage this encryption in a scale, right? And suddenly, again, and this is a reminder, I'm a developer who is hired here to support a banking application, and I'm spending majority of my time dealing with InfoSec, trying to see how can I build this network, like specific security stack for my application to basically, to hit a production, right? So, and this is just the problem statement by itself, right? So, and with that, when you think about security, yes, I do talk about encryption. Encryption drives authentication as a need. How to make sure that service B actually being consumed by the valid service A, right? Or how to enforce service B only to be consumed by service A, right? And you see, this is the language of services. It's not a language of IPs. It's not language of the Again, it's independent of an underlying infrastructure. It's about services talking to each other independently of where they reside on, right? And once again, how to achieve this, right? Then change the gears completely. Observability comes in also to the picture, because you can't commission an app without that app the app must emit the metrics, because you still have to understand what's going on with your app, right? And I'm not saying about like a load balance. I'm saying like you have an application service that has to emit the metrics in order for you to monitor your own application. So guess what? You have to establish basic monitoring. You somehow need to figure out how the service will emit the metrics, how the service will emit the traces, how that service can be actually monitorable service. So because what? Because again, you have a statement. You cannot just commission up without observability being accounted, right? And it goes over the head as you go. I think the most, sort of appreciated, underappreciated complexity, observability brings a lot of complexity questions to it, right? So, and eventually you end up at the point of, I have that many, challenges around me that as a developer, it's important to say it, as a developer I'm facing. And is it nonsense? Yeah, that's why you'll find the teams, you'll find multifunctional, cross-functional development teams, where you'll find here's the guy who's our network expert. He's not a network infrastructure person. He's a network library person expert, right? Whose job is to actually full-time job as a software engineer to maintain the network libraries that do pertain for the specific application. And this is my BU1. And then in BU2, there is another developer who is responsible for the metrics and stuff, and so on. And usually those teams are, application-centric teams, meaning that those teams are built for the specific application. But then when you go to the banks, like in really large banks that run more than thousands of applications, you figure out a massive duplication of those roles and functions and massive operational overhead to actually run, those applications. That's quite hidden, because it's not in the platform realm, it's not in the infra realm, it's in the software engineering realm, and in fact, it's very, it's very hidden overhead that is there, right? So, and then does it mean there are no Binaza solutions around? Does it mean like you really need to have, like that's like I almost, I'm trying to stage it, yes, you need service mesh. But it's like there are things that were happening before, like a prepackaged libraries. For example, like Netflix done a great job about like generalizing and advertising, let's say, service registries such as Erica, right? Or like client-side libraries like Ribbon, for example, right? Those things, again, they are libraries. They are in-application processing, right? So meaning that you can take those libraries, package with your app. Technically, they're well-known libraries that can technically will offload you of thinking that you have to manage to build something on your own. And technically, again, back to the shape. Well, I'm limited my involvement in those libraries maintenance. I'm just basically signing, and this is just an examples, right? There are a bunch of them. There are like millions and gazillions of those, right? But the thing is there, they are in process, and that's the key word that I want to call out here. That means they have to be coupled with application code. They're not transparent for developers. Developers have to study and know them, and you still have to support them as a developer, right? So basically, how that scale or how that works. In fact, that's, long story short, a simple answer short is it doesn't work for all the cases. It's not an answer for all the cases. I mean, of course, if you Netflix like or you Google like or etc., you have enough army of developers that works for you, and your application is more or less sort of done in the same shape and fashion. But if you one of the financials anywhere in the globe, and technically you see I will have financials because technically my life for the last 10 years been supporting financials in different capacities, right? And you'll see, you'll see literally a zoo. To any financial you go, you'll see a zoo of all kind of applications that they run. It's not unified in any way, any shape. It's like, and it's not even a zoo. It's something even beyond the zoo. I don't know how to call this out, but this is something like, it's like between a zoo and something more extravagant. So with that, the bottom line, in process is good. It may work, but it's not, an answer to all, your applications or let's say answers all questions that you may have. Let's say. So that's where let's talk about Envoy. And there is no this is like a segue slide, but in reality it's follow, right? I want to introduce you something that is actually out of process, right? And then and yes, I will call it Envoy in this case, and this is the proxy and etc. We can talk about it. Yes, what is Envoy? Envoy is a proxy, born and left. Why? Because guess what? They tried to migrate to microservices. They realized that they cannot achieve unified in-process library unification to actually land all those zoo-alike, services to unified model. And with that, they came to the conclusion we can't do this inside of app. We have to externalize it outside of that. Meaning that here's my service, but can I couple something as an extra layer to it that will basically handle those identified concerns, right? And technically, if you'll see just what I was talking about, a lot of those concerns will be about traffic management, right? Traffic management from the point of just pure request handling, or traffic management from the point of what? Of security, or traffic management from the point just observing the traffic itself, right? So that's where Envoy sits. Envoy sits between the services. As the service A runs, you'll figure out there'll be a little instance out of a process or out of a processor that will basically crunch your data for those specific reasons as I was talking just before. And to sum this all up, right, that's where basically why Envoy appeared. Why? Because, and in fact, it's we do show and we tend to showcase Matt Klein here as technically he was the creator behind Envoy, but for example, one of our founders like JJ Pragash, for example, he was also part of the Twitter, for example. So Envoy, yes, Envoy was born and lived, but technically, as it was born and lived, there's a lot of companies been having similar issues, and eventually Envoy's CNCF project that basically they all looked around and they did realize that thing, in-process libraries do not work for polyglot world or for your zoo of apps, right? And that's where Envoy came to the point of being that out of process solution. And why not exist in Nginx, for example? Why not something exist in as of today? There was a very specific points behind it. One, it must be lightweight, right? Because you cannot introduce the overhead that will be basically beyond or what, because think about that. We talking about introducing an auto processor. That means a process number 2 will handle a traffic for each of the service instance. So it must be lightweight, right? And it must, I guess I just realized I didn't click the slide. It must be lightweight, it must be programmable, right? And that's what Envoy was built for. Envoy was built on the point of being a lightweight, attachable proxy to minimize that overhead, but in the same time, address all those issues that are there, right? So with that, why, when you talk about service mesh, right? Envoy is that underneath component that is there to process your traffic. But majority of what we'll be talking and how we'll be talking is It'll be about how to manage this, how to apply, basically how to apply service mesh. So that will mean you will need to have a control plane to this. So Envoy by definition is nothing else as data pass, meaning that just a data plane element that have to be programmed. So what it means here, in this specific example, you have 3 different application instances, let's say 3 different ports, that basically what they will have. They will have, there will be an instance and there will be sidecar. And for each of that instance, there will be a sidecar, right? So with that, somebody has to program it, right? Somebody has to orchestrate a service awareness. Somebody has to orchestrate the traffic management. Somebody has to orchestrate the certificates retention. Somebody has to orchestrate the observability configuration. The orchestration has to happen. So the control plane has to exist, because Envoy, once again, is just the data bus, right? And that's where Istio comes in. Istio, that's your control plane for your data bus, right? And obviously, altogether, because Istio does bring Envoy as part of the installation, and Istio tend to be equalized to the service mesh. And in fact, Istio, it's one of the service mesh, software products that basically defines the vision behind what the service mesh is. But basically, where your foundational knowledge should begin from, Istio is a control plane for your data pass. Your data pass is Envoy, right? So basically, Istio provides you an interface to program your service mesh. And Istio provides your abstraction layer to expose those service mesh features to your application developer as is. So with that, I think it's perfect analogy here, and I tend to use it for a lot of different examples. But technically, Istio, it's a collection. Istio is overarching layer that, in this case, it's equalized and sits on top of Kubernetes. But once again, Istio, you can expand Istio beyond just Kubernetes. To begin a journey here, let's just basically look to this stack as simple as that. You have infra, you have Kubernetes. Kubernetes provides you ability to orchestrate your pods, right? Manage your services, deployments, after scale them, etc. With that, you have this basic layer. So then extra, Istio brings a service mesh capabilities that you can choose and pick, such as your Lego blocks that you can apply for your different services. So would it be just a service discovery? Would it be just a service-to-service encryption? Would it be just timeouts and retries management? Would it be simply traces and metrics, right? That's basically what Istio is. Again, Istio is a control plane that will orchestrate your data path, which is Envoy. And then Istio itself will provide a set of APIs or set of the configuration elements that will expose those functions to developers, right? And throughout this class, throughout those, how many sessions we have throughout those 4 sessions that will have, we will actually go and uncover all those building blocks or Lego blocks that we have. We'll talk about simple traffic management use cases. We'll talk about more, extravagant, let's say web assembly use cases, where we can talk about how to run WAF, for example, for a given service, right? Or others elements, right? So, but with that, this is where, I want you to, capture this, right? I want you to understand that Istio, it's a realization interface that basically will program your data path. All the magic will happen in data path. But trust me, Envoy data path is not Envoy configuration is not the simplest thing to do. That's why the overarching control plane exists, right? So a first lab approaching, right? And this is where I don't expect you to do lab right now. Because once again, as we'll finish through this session, through these 2 hours, you'll have sort of a homework to figure out how to run those 2 labs yourself. You'll have homework to figure out how you'll run those lab exercises yourself. With that, what I want to do, I want to showcase you those options right now, and I want to spend time on basically on a lab environment and how to execute those lab environments. All the labs that we'll have throughout this class, I'll be doing with you. So I'll be showcasing, I'll be demoing them. I'll be providing more insights than just a lab guide talks about. I will be basically spending as much time as I can to basically open up on more of those. And lab is the perfect wire to basically have a conversation about, hey, what we're doing, why we're doing this, etc. Right? So let's get going. So there is a first link, right? There is a link number 1 here. I'll send it over here in the chat. This will be a first lab that I'll be doing. However, first I'll spend time on environment. Right? 2 links that I sent, the environments, right? That's what I talked about, right? So environments, you can get your own, Kubernetes environment, right? This is like basically you go 0 to 60, it's a public page. A lot of the stuff that I'm showing here, we technically do evangelize, and Tetrate as a company, we're behind 3 open source projects. We're behind Istio, we're behind Envoy, and we are behind Skywalking, which is the observability stack. Technically, we do position ourselves more as data pass company, so majority of our contributions are against Envoy. But what I want to say here is a lot of the materials that you see here, it's not like it's not internal, it's external, it's publicly available. We do have people that do those webinars frequently about those topics, and those materials actually getting updated all the time. So the links that you'll get, what you'll see, the materials will be updated. So, and it will be quite fresh. So you can see here, like Istio 122 came out literally like a day or 2 ago. I don't know, time flies. So, and it wasn't me who was updating this for 122. So, but with that, there is lab environment. We will be doing all the labs from this page where you see like training Tetrate.io. The question that you'll figure out when you will log into the page, there'll be a password asked, and the password will be Tetrate123. I send it in the chat, right? Because this is a password protected link. And the second link, well, it's not a password protected link. This one. So with that, how to get your lab environment, there is like basically GCP way, there is a killer quota way, and killer quota may work for some of you, because technically, if you go to killer quota, it's sort of a cool way of to code the environments. So if you'll see here, you literally go to Istio 0 to 60 class. And you don't necessarily need to follow the lab here, but what you'll end up immediately with the lab environment, right? Which technically free of charge for you. So you log in, that's it, you have the lab environment. You can go and follow this, you can go and figure out yourself. Here's my cluster environments. I have already the environments I can already work and play with, right? That's it. So that can be the most easiest way to begin with. Right? Doing those labs, right? Also, for some of you, like who run those labs locally, I believe K3D is also a perfect way of doing that. Again, it's cheap, effective, and basically that's once again their instructions how to do so. It's all there. Just go begin on it. That's it. So with that, what I will do next is I did provision my own cluster. I just like I tend to have like the environment this is just a GT cluster. What you'll see, I have a couple nodes clustered that provisioned yesterday, the day before, right? To basically, do this class and talk about that. So let me, start talking about, Istio, right? Because technically, I did introduce Istio as a control plane. Again, Istio is not only service mesh. A solution is, in fact, it'll be interesting as we'll be going through this. You'll see we'll be talking a lot about single cluster use case, single cluster, how to do this or that within the cluster, right? But then, as you go and, look for more complex or production grade environments, those concerns actually scale. Those concerns scale from the point of multi-cluster concerns, multi-regional concerns, etc. This is not something I'll be covering this stage. I think what is important right now is basically do touch on importance or on those Lego blocks in a micro scale or on a single cluster scale. And then as you will endorse this, John, you'll per se one of your companies you'll be working at, or you're working at, you'll be endorsing this. This is where you'll know your way. You'll know your way in, and basically that'll be quite a continuation of this. Because, for example, my day-to-day job is basically work with the customers on basically applying service mesh and scale, applying service mesh for large enterprises, and like any of those concerns that I'll be talking to you sometimes really do take a lot of time to basically lend it. Like, give an example, simple retries and timeouts for the services that run on scale of thousands, maybe by itself a challenge to land, right? And takes a few months to basically properly set it in production. And I'll be talking why it can be like that, etc. Right? So with that, if you'll go here right now, so what I'll just put this on the side. Hold on, let me just do this and do this so you can see my screens on both sides, right? So basically, Istio journey begins from Istio Cattle, right? As it sounds, right? So, which it's the first, it's the first thing that starts from, right? And technically, I don't use Istio Cattle for the installation, but basically, what you'll see as part of this class, there are a bunch of things will look quite simple. And in fact, this is how it's built. It's built to look simple. But as you endorse it in production, like, do you install anything using the cattle? Like, for example, the first thing that you may think about is, hold on, if I run something like Istio, right? Should I once again use Istio cattle to install it, or should I use more generic ways like Helm, for example, to install it, right? And you'll be right. For example, enterprise grade or production grade installation will not go from the point of, hey, just what is there? Like, go in Istio cattle, fine, thumbs up. Okay, so what do you do next? You just do what? Istio cattle pre-check, and then basically Istio cattle pre-check will give you, oh, your cluster is ready, and then basically you go and do Istio cattle install, and you off you go, and you already cluster installed. That's perfect, because like this is built for the lab case scenarios. This is built for the people to begin the journey with Istio, right? But technically, as you open the chapter, is if I want to install Istio in enterprise, what those things are there? And it won't be just Istio cattle install and you have Istio ready and you begin your production grade journey. No, there'll be more things to it, right? So by the way, because I want to check my version. Yeah, it's 121. I tend to stand on the production, like on N-1 per se. I didn't yet try myself 122.0, so basically I'll play safe here, and I'll let you endorse the latest and greatest from Istio community. So by the way, when you talk about Istio, right, there is you'll find a lot of like, this is, we had the point release at 122. Istio by itself is what we talk about. Is it like, are we approaching like 7 years anniversary? Was that? Yeah. So project matured a lot. This is like Alan myself, I've been working with Istio for the last 4 years, and I've been working with the customers that been working with it like for more than 4 years. So in a production, right? So you'll find those release notes are quite massive and on the par with Kubernetes release notes. So and you'll find a lot of things that that are there that once again this is a perfect way to understand the release. Just again the heads up, I want to share more with you. I just don't want to do Istio cattle installation and say, hey, I have Istio running, what I want you to set on. A lot of your answers will be found at Istio page, right? Specifically documentation. And that's where you'll find a lot of those things that I'll be doing there. I'll be talking on. They'll be here, right? Obviously, it's open source project, so Istio GitHub also has a lot of other answers per se if there's things do not work or why they not work. And I'll be talking about that from the point of if they're perfect, it's a perfect source of information from the point of if I'm doing something this year, right? Like, am I doing something off, right? You can always find, a lot of insights in the issues, right? Lately, discussions been released. Discussions, it's basically community endorsed way to support all the conversations that you may have around Istio, consumers may have. So basically, the way that discussions are framed right now. So and that this is like a general Istio community decision is to route all the questions that you may have throughout this discussions channel, right? So basically, you'll find here the questions is like how to basically this is just the basic questions that people ask. So which is also a perfect way to learn Istio as well, right? We also have there are a few other things that I will call out and I'll be sending links on, right? There's Istio Slack community, right? There is a lot on Istio Slack community that you'll find. So basically you can join Istio Slack, and this is like a non-stop, like a fire horse that the information never end. Those channels are extremely active that you can find a lot of information over there, as well as you can also ask your questions over there too. So you can see 12,000 members there. Via StatRate, we also run TETRate community. So we have sort of our Slack a smaller one, but it's about TETRate. It's not just Istio, because technically via StatRate we I have to talk about TETRate by multiple reasons. In a way, it's a sponsor of this event too. And the second point is where I'm working, and it's my last 3 years of my work is basically in TETRate we talk about Istio, right, and enterprise consumption of Istio, also Envoy, and there's something else that you may hear me talking. It's Envoy Gateway, which is technically an ingress controller that Envoy-based ingress controller that we also ship into enterprises, right? Again, those Istio Slack community, TETRate community, they open communities that you can join. So to continue with that, so as I was talking, so this lab solely focuses on the point, hey, can I do my pre-check? Yes, thumbs up, the environment is ready. Okay, can I do install? Yes, you can literally, it's as interesting as it is, you can do just Istio icaro install, and it will tell you, well, there is the default profile will be installed, and you'll say yes, and after magically it will get installed, right? So once again, this is a demo way of doing this. This is a quick way to bootstrap a platform operator to get to know Istio. So it fits the bill. Is it like a production way of doing that? No. When you go and install Istio in production, you start from the helm. This is what there are two models. Actually, there's an operator driven, but now it's technically there is only one way to install Istio in production, is using the helm. So with that, when you have installation happen, and something you'll see here, there's a profile, right? Again, those profiles are technically, if you look there, like again, if you look, you can do help, and you can see a lot of those things there, right? For example, like how to set the options, all that stuff. But those profiles, they're literally just the profiles that basically have presets, right, of specific configuration elements. But again, they're built on the point of like, let me package something quick so someone can see it, but this is not like something that like you need to focus and learn. Hey, do I need to learn what those profiles are there for? Not really, no. So it's like, oh, well, this is a different extreme to it. Like, can I customize my Istio Cattle installation? Yes, you can customize Istio Cattle installation, but this is much bigger conversation by definition to have, right? So with that, like, did I run Istio Cattle verify install command? So there is verify install sort of neat in a way, because indeed it will check any install, right? And you can see here that's basically that's what happens. It does go and checks validity of install. And what you'll at the end of the day, what you'll get here, you'll get to see that Istio system name. Oh, well, one more namespace was added, which is Istio system namespace. Within that namespace, what you'll figure out there, it's a couple of deployments pop up. One is your standard Istio. Well, this is actually the control plane itself that, as I was talking about, that's responsible to managing all those Envoy proxies. That can be sidecar proxies, that can be actual gateway proxies. And one of those things is a gateway. This is nothing else as a gateway. This is a gateway deployment. So this is just a gateway deployment, and this is where a lot of those assumptions may begin. Well, if I install Istio, by definition, it will install gateway. No, it will not install gateway by definition. No, this is a demo profile. This is like when you do those commands, you get in a demo profile. So if you look here, right, there's a page that talks about different profiles and why they're there for. In fact, you'll see here, this is like a collection of those profiles. So default, right, default profile installs Ingress and Istio. There is also demo profile that technically for me it's the same. It installs Egress. Like Egress is a way different conversation when we talk about Istio. We'll touch on that. And then basically what you'll find minimal, which is technically, again, like, should you use Istio Cattle to install minimum profile? Still, not really. It's like, if you go to installation mode, and install will begin from the point of install with the helm. And this is where you basically, how to install with the helm, exactly what you want to install with the helm, etc., etc., etc. Right. So basically, from the point of this production grade deployments, there will be not just as you can see here. This is like, again, I did helm install for CRDs. I did helm install for Istio, but important to say that you want to actually install multiple revisions of Istio too, because eventually this is a software that you employ, which will be part of your platform that you want to rotate. So that implies that for production grade deployment of Istio, you want to install multiple revisions of the Helm and basically rotate those Istio deployments as you go through. But this is more like advanced topics that we don't necessarily cover as part of this. Also, if you go the enterprise grade installations, what you'll see here, a lot of those installations have to be FIPS compliant, right? For the FIPS compliant, for example, Istio binaries Envoy binaries, they don't necessarily FIPS compliant. If you want to have, FIPS compliant Envoy binaries, well, for example, you have to go to us, or to others that ship Envoy with a FIPS. Open source Istio doesn't ship a FIPS compliant images, right? But for production, like the installations, in fact, FIPS is very much needed. It depends on the industry that we're talking about, right? I'll probably stop for a second. It's 2 p.m. right now. Are there any questions? Like, feel free to, just unmute yourself or write in the chat.
Sergey, how many years you are working with Kubernetes?
With Kubernetes, I started working in 2000. Well, my first OpenShift deployment was 2017. Yeah. since 2017, yeah. So
You
yeah.
start with Red Hat distribution, with OpenShift, not with vanilla.
No, well, the Kubernetes was there, but actual first production grade deployment was OpenShift. Was OpenShift 3 was something really early, but to be fair, like production deployments that I've been involved, they've been OpenShift, then went to cloud, and then I start seeing again of OpenShift. But I also was part of Red Hat too, doing OpenShift. But basically, yeah, it's a mix. It's a mix of OpenShift and the Kubernetes itself. So.
Thank you. One question from me is, so I'm right now working in Team, so we are supporting like Fuzzy Group, like big Ukrainian retail, and we are starting to have like discussion to use Cilium, not Istio. What do you think about the future of Istio regarding of other competitors?
Well, that's actually interesting, right? So, in fact, there are two different dimensions, right? So when you talk about the service mesh itself, right? When your use cases start from the point you just want to enable MTLS, right? It's sort of hard to say, should I run my Envoy, right? Should I have this extra overhead if I can technically achieve my encryption at the CNI level, which is Cilium, right? And this is where they mention, like, if your use case starts from the basic encryption requirement, this is one story. But if your use case starts from the point you're trying to build a distributed API gateway, your focus is on your L7, on your application itself, on the things, how you will do request handling, how you'll do traffic management, how you empower the resiliency, how you'll do multi-cluster resiliency, how you do multi-regional failover tolerance, and all those things. This is where like those things are being elevated from the like Cube API dimension to more like a bigger dimension, and from the point of the use cases, we go from the point of L3, L4 to L7. And this is where, like, in the end of the day, what you'll see, and I also have my customers, you'll still see the mix. And in fact, that's what we see right now. We have, let's say, Calico deployments, we have Cilium deployments, but the service mesh still resides on top and does provide distributed API gateway functions or like authorization functions that basically go beyond just IP-based controls, but goes from the point of how you overlay the WAF capabilities in distributed fashion, for example, right? So so that goes to point, right? There is a place for both. Do we see that eventually that you will have Cilium, you have eBPF, and those L7 extensions will be pulled? That will change the game. At this stage, it's not there, right? At this stage, we see Cilium as it's technically, yes, we see a lot of observability conversations, but from the traffic processing conversations, right? It's not at the L7 level. You still need to have a proxy, right? Proxy will not disappear. Somebody has to host and perform all those translations and traffic manipulations, right? So will service mesh, how it will basically assembled, change? It may change. So eventually Envoy will be at one place, the Cilium data pass and interception will be in another place. But like, doesn't mean that you still don't need to have, for example, Envoy. No, you will need to have L7 processor, right? Where Istio D will fit in here, would be Istio D sufficient? Would Envoy or Cilium, for example, now will intervene and will take over of Envoy? And this is a lot of things that are there, for speculation. But this is like we talk about, this is like, we talk about the future, right? If you'll go and see the customers in reality right now, right? Service mesh, it's just taken a real traction, right? And Cilium, it's taken just a real traction, right? From the point, I'm not talking about just simple port-to-port communication. I'm talking about ability to use Cilium for more than just port-to-port communication, right? Same for Istio, not use just Istio for MTLS, but do more, right? And so that basically lots ahead of us. And I think when I joined, Tetrade 3 years ago, I thought service mesh will be adopted much faster in the wider audience per se. But what we really see right now, it's the market is just picking up. Like seriously, starting last year, just it's picking up. It's not been that active, right? From the point of it's a lot of complexity to swallow, and for the benefits, right? So basically, so it's a platform responsibility to take on that. So it's a lot still needs to happen, right? It's still like this is still emerging technology. This is not yet commodity. Envoy hitting the commodity, but Cilium is emerging technology. Istio service mesh is emerging technology. So that means, like if you look for the production grade functionalities that it provides versus all the functionalities it provides, the list is shorter than it should be per se, right? So that means, can you do with Cilium this? Yes, you can, but is it demoware or is it production grade solution? Same with Istio. There are bits that are real that customers been using for years, and some of that is demoware, but it's there, but like are not yet proven by the time and consumers, right? So basically that's where we always need to basically cut this hype and basically use a mixture of and the best of both technically. So, and that's what we advise the customers.
Yeah, I have I think the picture, the more or less the same. So for example, you have some sort of interview, you starting been asking by some interview guys and about some modern frameworks, modern technology. But when you actually started to work on this project, so maybe in the best ways, maybe 5 years of outdated tech stack. So I think if you're talking about like production ready solutions, they usually like old, not modern and fresh.
Yeah, no, it's exactly it's a difference between demoware and then KubeCon like materials, KubeCon like companies, and magic unicorns, and real reality and or reality as is, right? And I think but that's the focus, right? I think the focus behind the company where I am is basically our focus is to deliver the functionalities that customers can rely on scale for long run, right? Because that's it. Because it's a data processing, right? It's a very different ball game when you're in data processing, right? And throughout all my life I've been in data processing, right? When you observe, it's one story, but when you process the data, it's a way different responsibility that you take on. So yeah.
Yeah. Any other questions, guys?
Okay. Can we use Istio with any container network interface?
Yeah, you can.
Okay.
So that basically Istio runs on top of, it's disconnected from CNI itself. There are gotchas and more things that you can do with CNI technically, but by definition, it's CNI independent. Because that's how the traffic interception works. So there are benefits if, for example, can you use a Cilium native way to intercept the traffic? Or can you use a standard off-the-box way to intercept the traffic? But in the end of the day, both of those things do work. So
Thanks.
yeah. So yeah, so from the CNI standpoint, like what I see on the market, yeah, it's like again, like usually like what we have, OpenShift, like OpenShift, it's I mean it's more like a bigger animal per se by itself, but it has own CNI like OpenShift SDN, OVN, yeah, all those things are there. Like again, the interception happens independent of CNI. It happens based on IP tables, and we'll talk about the interception, how the traffic interception done in this lab, not in this lab, the next lab. So once again, as we talked about that, Istio cattle, that's the utility. Well, Istio cattle is your utility. Like as you frequently use kubectl, as you onboard the mesh, Istio, the Istio kernel will be quite a utility to use. So that's why I don't think I disvalue the utility saying, the only thing that I will say, don't use it to install. The rest is utility that you will need quite frequently to understand what's going on, right? It's more like your day 2 troubleshooting utility. If there's things and stars don't align, why? So Istio kernel will allow you to understand a lot behind what's going on behind the scene if something doesn't behave. So for production grade installations, do use Helm. Keep in mind there are a few charts. Do revision your gateway separately. Do revision your Istio deployments, and a lot of that is documented there. So from that standpoint, right? Again, we also post the links around the like installation, like there are other things that we do post about the good practices and so on. Just one of those links to share too that you'll figure out, right? It's technically it's the same Istio distribution built by Tetrate, right? And basically we provide our own reliability and the build processes behind that. And TID is like less important. I think the core is TIS, and where the TIS is where we provide 40-month CV support, where we provide the FIPS validated builds, etc. But this is again just to mention in this context, but this is more or less irrelevant for this conversation that we are having right now. So let's keep going. So Istio, right? Istio, your control plane that is there to orchestrate your Envoy, right? But Istio orchestrates at the first step before orchestrating the Envoy configuration, it will orchestrate the sidecar injection for your given port, right? For your given instance, right? So I mean that Istio will be responsible to inject an Envoy sidecar. When the sidecar pops up to deployment, Istio also is responsible to reconfigure pod networking, right? To do what? To actually intercept the traffic, right? That'll be IP tables driven process, right? But that's a task of Istio, bootstrap Envoy, and when intercept traffic and send all the traffic to Envoy, right? And then there is a lot behind it will happen behind the scene that Istio will be responsible. Will be responsible for certificate management and rotation. Will be responsible for the service discovery. And service discovery and technically discovery process Envoy includes Envoy nature behind this. And this is basically where I want to spend a little time on this and go to this Tetrate Academy stuff. This is all free. Like this is sort of things Tetrate provide for free that, for us, it's a marketing material. Of course, it's a lead generation material, like tool. But for you as a consumer, it's another Istio class that you can, get for free. So Istio fundamentals, that's the one I'm delivering, and there is also Envoy fundamentals. And this is that will talk a lot about Envoy and how actually Envoy behaves, right, behind the scene. Because technically, that's important to say is Envoy, it's a product by itself. You can utilize Envoy without Istio, right? It happens when you talk about service mesh, sidecars, Envoy, data path for Istio is Envoy, but there's lots happening within the Envoy itself that will be a way different conversation to have. But what is important to say, Istio is responsible to program the Envoy. Envoy by itself has discovery from it's like services. What would be how to discover the endpoints, how to discover the clusters, how to discover the listeners, how to discover the routes. There is a Envoy specific terminology that I brought up for a reason right now, and I don't explain it. But there's an XDS, any discovery service, basically Envoy APIs are built to discover those elements, so eventually the configuration can be programmed. And I will detail that as I will be doing the exercises, I will be detailing this, but there's lots is there to bootstrap the configuration of Envoy. There is lots behind the scene that happens, right? But the general picture that begins in your mind is nothing else as you have the Istio as your control plane, And then you have services, for example, service A, service B. Each of that service will have a sidecar attached to it, right? This picture, I have problems with that picture because it does say ingress traffic, egress traffic. Yeah, in the visual terms, yes. Basically, service, when traffic leaves the service, it will basically egress and ingress through the sidecar, through the proxy, right? Basically, pod deployment, right? The pod itself will have a sidecar, and traffic in and out will be intercepted by Envoy, right? None of the traffic can bypass the sidecar. You can also ask the question, can I configure the bypass for selected traffic? Or for selected port, yes, you can do traffic bypass, but it's more like a configuration option for more like advanced use case that where you want to bypass sidecar injection for the specific port, right? So with that, Istio is responsible for the discovery, configuration management, and also Istio will be your certificate manager or can be a certificate signer, right? And we'll talk about certificates in the certificates and service mesh. It's a conversation by itself to have. But at this stage, what I want to focus right now, I want to open this picture up and talk about what is a pod. Pod runs an app. Now, what is a pod? Pod has app, and now it also has Istio Proxies as a container. This is, in fact, as you install Istio, as you label specific namespace for the Istio management, then any deployment, any deployment that will instantiate the ports, all those ports will be mutated with that Istio proxy sidecar attached, right? So because Istio by itself, behind the scene with Kubernetes, doesn't inject mutating webhook, and as pod will come up, as deployment will come up, it will mutate all the deployments that it's looking for to attach the sidecar, right? So with that, what will happen? The actual, you have your standard deployment. What will happen? This Istio sidecar injected, which is mutated webhook, will transform an actual rollout of a pod itself, right? And that's what you'll see as we'll be looking through the lab. What you'll see here, the actual pod that will come up will be mutated, right? So with that, what you'll see here, this is your pod now. You see that blue line here, it's a pod, an instance, right? Within that, there is one container is your app. The second container is Istio Proxy. Istio Proxy by itself runs two processes. One is pilot agent, because pilot agent is an actual physical task for the when Istio Proxy comes up, it needs to reach out to Istio, do a handshake, initialize the envoy, and then basically, so pilot agent is a micro, or let's say a micro control plane for that given instance to initiate the handshake with Istio, and then when pilot agent will trigger the handshake with Istio, which is the control plane, right? Envoy will be programmed, and Envoy will be responsible for the continuous traffic management, right? You'll see ports like 15001, 15006. So this is actually a quite loaded topic to have, and I did on purpose, was looking for one more loaded link. There's a lot of things happening behind the scene that not necessary. Say this is, I think this will be a good link. Just another book to share. And it's a book, right? There are a lot of good stuff there, which basically we'll talk about like inside of Envoy. We'll talk about like how the injection happens. But what I want to show you is actually how these ports and components. Yeah, this is the picture. I want to show you. That's, by the way, it's all open source. It's all free. It's all available for everyone to be discovered and looked on, right? So I just want to show you that, like, if per se you have because this is like, is there somewhere a single slide or diagram that documents all the nonsense or madness that happens within the actual given pod? Yes, there is, right? And you can see here, this is all the process that happens behind the scene, right? And it's quite interesting, right? But what I want to pull out here is the way how traffic, and this is like, again, it by itself, like, to be honest, I mean, this is the most frustrating part about Istio and Envoy by itself. Like, I've been like, yeah, I've been working with it like since what, 2019, I think, or 20, yeah, 2020 maybe, yeah, 1920 when the COVID started, like, yeah. But the point is, there's always something new, or there's so much there, so it's sometimes it's hard to keep it all, to keep all these things together when you analyze those elements. But I'll send you this. I did send you the link. There's again, I'm saying this, there's a lot of things behind the scene that if you really want to go and understand in very, very details how it works, there are more of documentation around that, right? But the bottom line, which is the very line that I want you to understand, that the traffic interception here, port 15001 or 15006, pile attention, what it triggers a collection of IP tables commands that basically will perform a full traffic interception. So when Istio, when pod comes up, as part of the pod, there is a sidecar called Istio Proxy. Within the sidecar, which is Istio Proxy, right? There is a data pass happens, but that's something that you don't see here. There is also Istio agent. When pod comes up, there is also Istio agent that will go in and instantiate those IP tables rules, and it will disengage. So meaning that what I want you to remember from that is sidecar has Istio proxy. Istio proxy, when it comes up, it will talk to Istio D, it will be ready to process the traffic. But before that, there will be a simple step when pod will come up, IP tables rules will be orchestrated by Istio agent. And that comes to the point. Hold on, that means that my application itself, or that pod deployment itself, or that role deployment, or that cluster role, or that service account may have permissions to poke with IP tables rules. Yes, it may or may not, right? And this is where we talk about there is a way within Istio to basically limit the configuration angle and orchestrate those IP tables rules separately, not within this process, but within the different process. But this is like a really complex stuff that I'm like, technically where I'm going with this is like, there is something that you'll find. It's called Istio CNI plugin. And what you'll find there, for example, in OpenShift by default, we instantiate a daemon set that will be responsible to manage this interception. And when I say manage this interception, do nothing else as IP tables management for traffic and interception. So that goes to the point, does Istio depend on CNI? No, it doesn't. But can you do non-IP tables based interception? But can you do like eBPF based interception? Or can you do like a Cilium native interception? Yes, you can too, right? But this is like different abstractive. So you can see here, like the product been long enough on the market. There's so much of different things that you have to be aware of. This is where basically when I introduce service mesh to the customers, or when I work with different customers, I try to limit the explosion of all those capabilities. Because think about that, when you employ service mesh or when you employ Istio, you need to understand there are a list of values that you want to do, a list of the use cases, and go and pick those 2 or 3 and start from those. Because a lot of what we'll be talking, there's so many different angles, so many different options, so many of that, so many of this. And it's like, Jesus, this is so complex. Complex means fragile. Why haven't I should handle this, right? And this is the point of open source, right? This is like that magic, right? That, yeah, but that's why, like, this is where we should slow down and say, as I'm doing this class and I have zero interest for you to buy something or so, I want to basically give you an idea. This is quite, there's a lot of experience and knowledge in the field. No, I'm talking about like company-wide. I'm just talking about the global field experiences that you may find a lot of different answers, right, for a single question. And with that, it's like basically buckle up and prep yourself to read, right? Basically, with what I just said, I said, is this complex? Yes. Should you know it? No. Will you remember that? No. But what are those, how the interception happens? What I want you to remember, it's IP table's job. How the IP tables can be engaged? It can be engaged directly by the process itself when the sidecar comes up, or it can be engaged independently by the daemon set. This is just the two configuration options that Istio provides, right? This is usually when I'm losing people and then they're supposed to drop off and all that stuff, you know. So, sidecar. That's where we finally come to that point of this is what we call sidecar. That's saying next to, right? And this is where I go here and say, for example, right, what I have here. Let's create this. I always try to do something different. I was doing, let me show you this. There is something that which bingo. So there's quite nice demo app that, like, just I want to slow down and then keep this conversation now simple because there's something simple called HTTP bingo app. Like this is like I like to use this app. Like basically in your free time, go figure this out. This is a nice app that allows you to do all kind of different data-related tasks, right? This is load balancers, ingress gateways, sidecars, etc. Right? So with that, what I will do right now, I'll simply go and install that service over here, right? And then something that I want you to catch is before installing that HTTP bingo app, what I have done, I actually also did say for this namespace HTTP bingo to have Istio injection enabled. So I'm on purpose did label this namespace to be watched by Istio instance to actually go and mutate all the deployments that we'll have with what? With an extra sidecar. So if you go here right now, right, and that's what I want to show you. If you go to deployment, right, to this HTTP bingo deployment, right, which is this one, right, and what you'll figure out here, it's a straightforward app, right? Think about that. That's it. This is the app. What it is. It's just runs this container, right, and exposes on the port 8080. That's it. Nothing else. You see nothing else here. Like simplistic app, right? One container, right? See, there is no more. This is just one container here, right? But then when deployment happen, you'll see here, if I'll go and describe this like specific deployment, what you'll find here is suddenly there are two containers, right? There is one which is, here is my app, right? That you can see here. And there's a second container, right? That'll be added, which is, you'll see here, it's called, see, this is the second container, which is the sidecar, right? That's what it is here. This is all being, right, it's Istio Proxy sidecar. This is all a task of Istio mutated webhook to actually go and mutate the deployment. When the pod comes up, Istio looks there and interjects basically and does the magic per se, right? So that's where you go here now and that per se, we have this deployment, we have Istio, we have, if you look here per se, right? What we'll find? We'll find that, oh yeah, there is that instance of HTTP bingo came up, and guess what? we pushed everything that we know to it, and that basically talks about, hey, yes, we registered it, push the configuration, thumbs up. If I go right now, right, to this HTTP bingo app, right, and then per se, right, and if I'll go do, what, let's do this, right, I'll go and see the logs for that one, right, there are a few logs there, but what I want to go and see there is this. Sorry, I just typed it too fast. So logs, but I want to, there are two containers. We know like there are two containers to this right now. There's one container, which is the actual app container, and there's another container that was added to it, a Istio proxy container. And what you see here that actually there is execution log. When this thing came up, what happened? And this is like, let me do it like this. What happened here is literally, yes, the sidecar was added. The configuration that was given to it, hey, this is the Istio proxy, you better go and talk to this Istio ID, and this is the set of extra properties that are there, go initialize. And then as part of the stack, and there's a lot happening here, but what is important to say here is the Envoy proxy initializes, it gets the configuration, all the necessary elements, and comes up, right? So with that, what we have here, we actually have a deployment that Vulkan, right? So now, like with that, I'll see this one. It's just more like a play utility that I like to. Then I'll do what I have another container, which is the Ford.io container, which is the Ford.io is more like a testing utility that you can see here. They deploy different namespace Ford.io, and what I have here right now, same idea. In this Ford.io namespace, I'll have this site. I will have this deployment. Again, it will be injected. Again, it will have sidecar. So technically, I have this is my service A. This is my service B, right? So the way that I usually tend to do those, I tend to capture both of those. This is why you'll see those commands. So I don't need to basically go and continue, like always look them up. But what I want to show you here, I want to simply run from Fortio, from my service B, or like for my client, I want to run curl against a HTTP bingo, right? So this is simple curl just happened right now. And to be fair, you can see this is utility. You can do so much stuff there. Like again, like when I'm using HTTP bingo, I literally using this this demo utility. So for example, if I want to send a request that will fail, or if I want to basically send a post, or if I want to produce like some other things, you'll find there is a lot of different examples here. For example, this is one of the ones that I like to do is errors or delays. For example, I want to generate a curl that will for sure will be negative. And this is here an example of me actually doing a very bad command because I'm doing load here. You see this, there's a Fortio curl that I was using, and there is a Fortio load, right? The difference between load and curl, what if I want to repeat the same time a few times? I use Fortio load. This is the same. This is the things that I will let you go and study on your own. I just want to let you know there is a test utility such as Fortio. There's HTTP bingo as a service that you can use, and there's a lot. It's a lot of in our job is try and play. Well, we also need to understand the theory, but this is more like I'm giving you more tools where you can basically appreciate the value of the service mesh quicker. I mean, of course, you'll figure out as we'll be going through this lab, I'll be using a very canned booking for app that every service mesh sort of guide uses, but I just want to show you something else that you might appreciate, right? But with that, you see I've done a few queries there, right? And what I want to show you here, right? I want to show you that logs for this service, right? And that's what you see here is this is the service, and I was doing all those logs, right? And I see nothing here. But doesn't mean that traffic doesn't fly. No, it doesn't mean that. It means that this demo profile doesn't have logs enabled. So check this out. I run this command, right? Few times. I know I run it against HTTP bingo service, right? And I see nothing there. So this is sort of a saying that what do you have right now? Yeah, 241, perfect. This is one of the homework items, like homework item number 1. Figure out where you'll run it. Homework item number 2. Yes, do install it, but do install it with the option that you can see the logs for the sidecars, right? Because by default, the default profile doesn't enable login, so you'll not see the request. And then that's how we'll start. I'm not ending the call yet, right? And the class yet, but this is just a homework item. Figure out where you will run it. And when you will install it, make sure that you will install your Istio deployment with a flag that will enable you to see the logs on any of your Envoy containers, right? So with that, let's come back. So sidecars, we understand what it is. Sidecar is your proxy. The proxy, it's L407 proxy, so you can do all kind of stuff. If it's L407, what you can do with L407 proxy, you can, of course, load balance, of course, manage your timeouts, retries, passive health monitors, encrypt the connections, etc. Right? All those configurations are managed by Istio, right? So Istio is your configuration interface to this. And of course, if it's L7, L4, it emits a proxy. Envoy does, by definition, will emit metrics. Envoy is smart enough, and this is where, once again, you go here, you go Envoy Proxy, right? And then you go get started. And this is like the most unfriendliest get started guide that I see not on daily basis, but this is the most unfriendly stuff. This is not built for the platform, like basically owners of platform operators, right? This is built for more like a developer. Hey, Envoy, okay, I need to start coding to Envoy. Okay, this is my page where I start learning what Envoy is so I can code for my Envoy, right? So this is like getting started, built for developers of Envoy, right? This is the most unfriendliest getting started that I do see on a daily basis. But what I'm trying to say here is Envoy, right, is L7 proxy, so it can intercept your traffic, right? What it means is that when it intercepts your traffic, it has different filters. Filters are like extensions, meaning that can it understand HTTP traffic and behave on HTTP traffic? Yes, it has basically HTTP filters, right? Can it understand MySQL traffic? Can it send the Postgres traffic? This all those filters are there for. So meaning that by definition, they're filters or extensions that will enable you, or not you, basically Envoy, to emit application-centric metrics. This is like by definition, Envoy able to understand the protocol. If it's able to proxy the protocol, it's able to emit protocol-specific metrics. So that's where I don't want you basically be lost on those for now. That's basically will be a good one for Friday. I mean, Friday, if it's not the right time in a way to talk about Envoy, but we'll be coming back to this page, right? So with that, now we understand that what the sidecar is, and there is a lot for the sidecar injection, right? So I, on purpose, did it beforehand, not upfront. This is something that I already tasked you with this lab, and this is not, I will not expect you to do this lab right now. Neither I will, this lab, what I don't like about this lab is basically focuses on the point of being solely educational. Like the example that I showed you, this is a real life example. This is how it will be. Like you just need to label in a namespace, right, to enable the injection. The Istio cattle cube inject command, right? This command, in fact, they want to get rid and remove this command completely. This is a solely educational command to enable developers or advanced Istio users to understand what cube injection is. But it's not for anyhow use in production or in any sort of, this is solely educational exercise. And this whole lab, why I don't like it personally, this is a solely educational exercise. It has no connection to reality. right? So that's why I tend to show you like your first interaction with Istio, not from the point of that lab, but from the point of, yes, there's Istio sidecar injection lab. Does it make sense? It's like, yes, it will help you to understand more, but will it bring you detailed understanding to this picture? It will not. So this is why I'm like personally, I don't find a value in this kube inject command and that kube inject value lab. But in the same time, it's there. Like some people do appreciate it, but this process and there's a lot of stuff happens behind the scene that like it still will not teach you about, right? So hold on, this is just one more bit that I want to have here. Just give me a second, sorry. Yes. Yeah, okay, that's later. Okay, so with that, that's sidecar injection. And this is where, what is that? Yes, this is where I want you to be at end of today, right? This is like my 2 hours goal right now is to let you understand. This is what we have just built out. This is my HTTP goal, or this is my this is my port IO. They both come up, they both registered, they both have sidecars initialized. All that happens by Istio. How much of the actual Istio knowledge I had to do? I had to do Istio Cato install, which I told you probably will do Helm. How much of Istio orchestration I had to do? I had to do Istio injection enabled. That's it. So technically, this is the persona issue, right? And this is what I want you to understand. As a platform operator and a platform owner or platform engineer, you will have to know Istio. So meaning that like you will have to know what is that, how to bootstrap it, how to basically maintain this best. But as a developer, I don't care. I don't want to learn more. I just want to have, okay, if you tell me that by default, as I deploy to this namespace, injection happens, and I get off the box connection between service A to B encrypted, don't care. You just help me to achieve my goal without spending any more time from my standpoint, right? Meaning that as a platform engineer, what you supply with Istio, one of the capabilities, it's end-to-end encryption for the services. If customer deploys to this cluster, end-to-end encryption is already achieved off the box. So, and this is where that balance, right, is developers should not be service mesh savvy. Like developers should just use the collection of the use cases, a prepackaged YAML files per se that says retries to or encryption enabled, those elements. Behind the scene, a lot will happen. But as a developer, you want to enable developer, not be service mesh expert. You want the developer to simply, do you address my service discovery? Do you address my service registry? Do you address my traffic encryption? Do you address my traffic management, reliability, canary use cases, observability use cases? That's it. This is like that mentality, right? That you should basically keep in mind. Like as a platform operator, yes, there's a lot of complexity that you package, but eventually as your end consumer, it's a straightforward task, right? So now it goes to the point of this example that once that easy to forget or easy to discard this change, but in the standard Kubernetes, how your traffic, from service A to service B flies, it flies through the kube proxy, right? Like as a container, what happens there? You resolve the endpoint. That's a kube proxy. It's a service IP, right? We talk about like that's where we talk about here, right? Oh, where is that? Oh, I somehow that's so KGAT, SVC, HTTP bingo, right? So basically I go here, this is my cluster IP. I go to the cluster IP, kube proxy will point me out one of the endpoints. That's it. This is like the Kubernetes fundamentals, how traffic management occurs. From container to endpoint, over the kube proxy, off you go, sums up. With Envoy, it's a different story. Proxy does not participate. With Envoy, the load balancing decision done outbound. So meaning that when service A wants to talk to service B, service A will be aware of all those endpoints and will load balance across. So cluster IP not needed. Istio pushes the endpoint discovery to all those envoys. Load balancing happens at outbound, not inbound, right? So with that, that's a very core difference. And this is where I want to show you something that I want you to basically begin this journey is I have my 4-tier service. This is a, remember I was deploying 4-tier, right? And I did this. And I'll end this very, it's almost like a one more slide to show and that's it, right? But check this out, right? What you want to really see here is this. And I did it on purpose, right? For when I go to HTTP Bingo and this 4.io sidecar, the 4.io deployment, you already know where to go. And this IP 6415, this is actually, if you'll go here, all white. Check this out. So this is to prove the point that Istio distributes the endpoint information to all the sidecars, and this and the load balancing decision is done outbound at the 4.io at the service A. When service A is talking to service B, service A is a client to service B, but load balancing decision done over there. And we will dig into this next time. I will be spending much more time on those elements. But where I want to end this conversation is, does everything just works out of the box? Yes, it still does work out of the box. How it is easy to install? It's quite easy to install, right? But is there a magic behind the scene? Yes, there is a magic behind. There's a lot of magic behind the scene, and as a platform operator, you have to respect that magic. But as a platform operator, your responsibility is not to let developer respect that magic. Developer should just get the prepackaged experience, right? So a lot of what happens behind the scene, a lot of that magic per se can be customized, and a lot of that being customized in the different environments, right? And with that, that's where we'll spend next 6 hours talking about different examples of customizations, or how these things happen, how load balancing happen, how timeouts happen, what outlier detection is, how to basically do encryption, and etc., right? This is where right now, at this stage, we got blocking environment with Istio up, with 2 services up, right? That's what I want you to do. I want to make sure you will go and do the lab, you will get your environment, you will enable login in your environment, which I didn't show. And when you'll be doing those tasks between the services, you'll see the log entries. And basically that will be the actual homework to execute on. And that's where we'll start the next call from. That's it for today. So we have 5 more minutes. I'll open up for the questions, if any.
So we don't need to use service in this case, or what?
No, you don't. No, the service is actually used in the behind the scene for the endpoint discovery.
Mm-hmm.
So you will need to create a service, right? But it will not be used in data pass.
Okay, but if I do request to service IP,
it will work, but the decision, the outbound decision will be, that'll be you'll land the proxy then. But with the sidecar, it will not let you do it. If you put an IP as is, it will let you do it. But usually all those communications between the containers, they name-based, and Istio will intercept the call, and it will intercept, if you're doing a call towards HTTP bingo per se, right? It will not let you use the kube IP.
Okay, so I can create service, but it won't work.
You will have service because we need service to understand where those endpoints are. See, Istio needs kube service to understand the endpoints.
Yeah, I am about like write to IP request.
But we will not write over that cluster IP. No, that cluster IP will not be used in data class. So that cluster, so that object will be only used to discover or to form, to discover the endpoints behind the scene. So basically, Istio APIs will look to the kube APIs. Okay, this kube service. Let me see what all those endpoints behind the scene, and that's where we spend time next time on Friday, where we will talk about exactly what is the Envoy endpoint, what is Envoy cluster, which is Envoy endpoint. It's nothing else as Istio endpoint, Kubernetes endpoint, but Envoy cluster, it's what Kubernetes service is. But then there is also Envoy listener and Envoy route, and we will cover that. Basically, I will do a full pass of the packet, sort of saying.
I think I understand now.
Good.
Sergey, what kind of automation do you have to verify your production grade deployment? So, for example, you have several clusters, you install a Istio on them, somehow you need to verify that everything is working. So, how we usually perform this task, like day two operations?
Yeah, that's actually quite a loaded question, to be honest. So first of all, there are Grafana dashboards and alerts associated with them that basically we provide a set for free to basically promote, hey, this is the active day two operational check on the clusters, right? But then does it still require your attention to validate those metrics, to understand what those metrics are? So that's why you have more like upper level product that basically has this like yay nay sort of stuff, right? But Istio of the box doesn't have yay nay sort of stuff, It has like basically it gives you, yeah, there's like thousands of metrics. Yeah, sure, go and read them and figure out the alerts, right? But this is like two-dimensional thing because you have to bless Istio, and this is like Istio blessing has to occur every time when you do upgrade the clusters, right? Because technically you love cycle Istio. And there's a second dimension, which is application-centric metrics and application-related test. So that's where we go and advise the customers. There's a platform-centric routine that you have to do that entitles, let's say, like as I talked about, or having the Grafana dashboards, have release checks that we have, and this is platform-centric routine. And then there's application-centric routine, like be ready that you have your application-related test. And when per se you do the configuration changes to Istio, make sure, well, you as a developer, make sure you run those configuration changes is in the service mesh through your SDLC. If you don't go change stuff in production, technically those service mesh properties follow your application throughout development lifecycle, right? So technically you will always stage that configuration in dev environment before promoting to prod, right? So I know this is not like probably the answer that you've been looking for, but like this is a loaded conversation to have. The day two with Istio, it's not a straightforward thing.